Hey guys, this lecture we're going to be looking at different types of chemical reactions. And so the goal here is to be able to identify the type of reaction if you're shown the balanced chemical equation. Now, we classify chemical reactions in a variety of ways. In this class, we're only going to be looking at 5 or 6 different types of chemical reactions. And so the first 5 we'll look at are combination reactions, decomposition reactions, single replacement, double replacement, and combustion reactions. Combination reactions are when you combine 2 reactants to make a single product. So the general scheme is, A plus B creates AB. This thing plus this thing stick together and make a compound. Combination reaction. Here are some examples. Magnesium and oxygen combine to make magnesium oxide. Sodium and chlorine combine to make sodium chloride. Sulfur trioxide and water combine to make sulfuric acid, right? 2 things makes 1 thing. 2 things, 1 thing. 2 things, 1 thing. Combination reaction. Here's an example of magnesium reacting with oxygen, doing a combination reaction to make magnesium oxide. We'll actually be doing this one in a later experiment in lab. It's kind of fun. Magnesium catches on fire, it burns really bright. Anyway, combination reaction. The next type of reaction is the opposite. It's a decomposition reaction. So a compound breaks into 2 or more products. So one big thing breaks into smaller things. Here's some examples. Mercury oxide breaks apart into mercury and oxygen. Potassium chlorate breaks into potassium chloride and oxygen. So one compound, multiple things. One compound, multiple things. So here's an image of the decomposition of mercury oxide. You can see it's releasing mercury and oxygen. The next type of reaction is a single replacement reaction. Now, in a single replacement, there's an element and a compound, and the single element replaces one of the elements from the compound. So in this case, A is going to come in and B is going to come out. So a single element is replacing another one. It's kind of like a cheating couple. Like this is a happy couple, and then C cheats on B with A, right? The trade partners. Here's some examples. Zinc and HCl. And the zinc is going to trade places with the hydrogen. And so you're going to have zinc chloride and hydrogen's all by itself. Here's another example. Iron and copper sulfate. The iron and the copper are going to trade places. So now you have iron sulfate and coppers alone. So single replacement. Here's an example of zinc and HCl, where the zinc and the hydrogen replace each other. And so the zinc is a solid metal, and the HCl is aqueous. It's just a solution of HCl. And the zinc actually dissolves, forms zinc chloride aqueous, and it releases hydrogen gas. And so you can see the bubbles of the hydrogen gas being released. Single replacement. The next type of reaction is a double replacement reaction. And so this is when you have 2 compounds and they trade places. So A and C are going to swap. And so now you have 2 new compounds. So With a single replacement, you have a single element and one compound. With a double replacement, you have two compounds. And so this would be like swingers that like trade partners. So here's silver nitrate and sodium chloride. And so the silver and the sodium are going to swap places. And now you have silver chloride and sodium nitrate, or zinc sulfide and HCl, zinc and hydrogen will switch places. And then you have zinc chloride and hydrogen sulfide. Here's an example of a double replacement. So you have aqueous sodium sulfate and aqueous barium chloride, and they're going to trade places to create solid barium sulfate and aqueous sodium chloride. And you can see that they're pouring a clear liquid into another clear liquid, and it's creating this white cloudy solid. That's the barium sulfate being formed. The next type of reaction we're going to talk about is combustion. And so combustion means fire. Okay. And that's when you burn something. So in a combustion reaction, you always have a carbon containing compound that burns with oxygen gas, and it always produces carbon dioxide and water, and energy is released in the form of heat. There's an example. You can have CH4, methane, reacts with oxygen, and it creates CO2 and H2O and energy. Or you could have C3H8. This is propane, right? Propane burns with oxygen, it creates CO2 and H2O. So you always have some carbon source. It's always going to react with oxygen gas, and it will always produce carbon dioxide and water. That's a combustion reaction. Now, a variation of this is called incomplete combustion. And this is when there's not enough oxygen to go around. So like if you burn something in a confined space, it'll start to do incomplete combustion. And the difference here is that it creates carbon monoxide instead of carbon dioxide because you don't have enough oxygen to go around. This is really dangerous. Carbon monoxide is one of the most toxic compounds. It's really lethal to humans. It binds to the proteins in your blood and stops you from being able to absorb oxygen. And it's kind of permanent. So if you get a breathful of carbon monoxide, it will ruin proteins in your blood until your body can remake new blood cells, essentially. And so carbon monoxide poisoning is really serious, and it's not really reversible. If you get too much, you're going to die. If you get a small dose and you don't die, you're going to be sick for a while until your body can recover. But incomplete combustion is when something burns to produce carbon monoxide. This is why they tell you not to cook in closed spaces. Like if you ever go camping, they tell you not to cook inside your tent because you can give yourself carbon monoxide poisoning. This is the same reason, or like committing suicide by leaving your car idling in the garage. It's a closed space, and so your car is burning gasoline with not enough oxygen, so it starts creating carbon monoxide. It's enough to kill you. So incomplete combustion creates carbon monoxide, which is really dangerous. That's why we have carbon monoxide detectors in our homes, because such a small concentration is so lethal. You want to make sure it alerts you if there's some in your house. And one of the first effects is like drowsiness, and then eventually you'll go to sleep because you're not getting enough oxygen. And so if you're asleep when there's a carbon monoxide leak, you'll actually just stay asleep until you die. So it's good to have carbon monoxide detectors in your house to wake you up in case it's leaking, so you know to like run out and get fresh air. So if they ever start beeping because the batteries are dead, don't just take the battery out, like replace it, right? These are a lot more serious than just a smoke alarm. And so here's a funny picture of Earth committing suicide from carbon monoxide poisoning. Okay, so here's a summary of the types of reactions. So once again, we had combination, which is when two things combine to form one compound. We had decomposition, when one compound breaks into two different things. A single replacement, a double replacement, or combustion. To do a quick study check, identify each reaction as combination, decomposition, combustion, single replacement, or double replacement. So the first one here. It looks to me like the aluminum is replacing hydrogen. So I think that's a single replacement. On the second one here, I have two compounds, and the sodium and the silver are switching places. And so this one's going to be a double replacement. This third one, we have nitrogen and oxygen combining to make nitrogen monoxide. This looks like a combination. And the last one, we have C2H4 plus oxygen making CO2 and water. This looks like combustion to me. All right, identify these reactions. So barium and nitrogen combining to make barium nitride. Well, that's definitely a combination. Two things making one thing. The next one, this one looks like a single replacement because the silver and the hydrogen are swapping spots. The next one, we've got carbon and oxygen making CO2 and water. That's got to be a combustion. This next one, lead and potassium are trading places. And so we have two compounds making two new compounds. So that's a double replacement. And the last one, we have K2CO3 breaking apart into two different compounds. So that's got to be a decomposition. Now, a separate way to classify a reaction is an oxidation reduction reaction. And so this is a unique characterization. These other five types can also be oxidation reduction. This is just a separate way to classify a reaction. Now, here these two pictures are just some common examples of oxidation reduction. The copper statue here is turning green from copper oxide, or this metal chain is rusting or iron oxide. So what do we mean by the term oxidation reduction? Well, this refers to a transfer of electrons. Definition is oxidation means loss of electrons and reduction means gain. You can remember this by the acronym OIL rig. OIL, oxidation is loss, rig, reduction is gain. So oxidation is a loss of electrons and a reduction is a gain of electrons. So if we have two elements reacting, if one element gives an electron to the other, it is being oxidized because it's losing the electron. If an element gains an electron in a reaction, it's considered reduced, or it's undergoing reduction. So oxidation is loss, reduction is gain of an electron. And so this happens most frequently with metals and nonmetals, such as copper and oxygen or iron and oxygen. So copper metal can ionize. So two coppers can form two copper 2+ ions and give off 4 electrons. This is known as a half reaction. On the other hand, oxygen can absorb 4 electrons to form 2 oxide anions. If we combine these two reactions, right, the electrons cancel. And so our balanced reaction is 2 coppers plus oxygen creates 2 copper oxides. And so this is what you see when there's that greenish blue corrosion on copper. The copper metal has reacted with oxygen in the air to make copper oxide. And so here's a picture of it on a copper plumbing pipe, some really old pennies. And this is actually what the Statue of Liberty looked like in 1886. So we always see it as like that iconic green, but it actually used to be shiny copper when it was new. So the green is just from oxidation over the last 100 and some years. So here's another example of a oxidation reduction reaction. So this is iron reacting with oxygen. So iron can form iron 3+ ions and give off electrons. Oxygen can absorb those electrons to form oxide. And the iron cations and the oxide anions combine as the ionic compound iron oxide. So the iron metal reacts with oxygen gas, create iron oxide, which is the red powder. So this is an oxidation and reduction reaction. Here's another example. If you have a solution of copper sulfate and you dip a strip of zinc metal in there, the zinc solid metal will start to dissolve as zinc 2+ ions, and the copper 2+ that's dissolved in solution will start to precipitate out as elemental copper. And so this is one way they can do electroplating or metal plating. So if you dip the strip of if you dip the strip of zinc into the copper solution, the surface of the zinc will start to dissolve, and copper from the solution will start to be deposited onto the surface of the metal strip. So if you pull it out, you can see that it's now coated in copper. So this is one of the ways we do metal plating, is through oxidation and reduction reactions, where one metal is in the aqueous phase and one's in the solid phase. And they do a really quick oxidation and reduction reaction and swap places. Okay. Study check. Identify each of the following as oxidation or reduction. So the first one here, it looks like tin is losing electrons, which would be oxidation. Here, the iron 3+ is gaining an electron. And so that's going to be reduction. And here the chlorine is gaining an electron. So that's also going to be reduction. So remember, oxidation is loss, reduction is gain. All right, so that's it for this lecture. oxidation and reduction reactions. Oxidation is loss of electrons, reduction is gain. And the 5 categories: combination, single replacement, combustion, double replacement, and decomposition. Thanks for watching, and I'll see you in the next video.